Now let's start the project with 4-story building. I will have columns for each floor different than others. Suggested size of columns is, for first column we'll have 360 by 196, and the second floor smaller, and the third floor smaller. And for main beams will be 460 by 158, and the secondary beams 200 by 100. We'll have an elevator shaft also 200 millimeters thick, concrete, and we'll add the exterior wall load on beams, which is 8 kilonewton per meter. So let's add this project, structures, and then we start with the elevation. Let's say the first level is 4,500, and then we add the other levels. So we have level, I'll pick, and I'll make this 3,000 offset. This is one, and this is the second. Skip. So we'll have these 4 levels. We'll just adjust the and we go to level 2 to do the grids. I'll do a simple grid. We'll have one first, and then we'll go and make offset of 5,000. 1, 2, so 4 of them, and then we go in the other direction. Again, we will have this one. I just change this to an alphabetic, and then back again to the grid. Well, again we do pick and we do offset. Let's make it 9,000. So we'll have 1, 2, 3. So I'll keep it simple. So this is our grid. Now we'll first of all start with the columns. We said the first level columns will be 360 by 196. So if you go to, we are at level 2, so we go down to, let's see if we have 360 by, so we have 360 by 196. We do a grid, and then for entire thing, and okay, so looks good. So back to level 2. We'll do the main beams. So I'll go to beams, and then we said the main beam will be 460, 158. So let's see if we have them. 460. We don't have, so we go to load family, and we go to structural framing, steel, and metric wide flange, this one. So look for 460 by 196, 460 196. There is no 460, so choose 460 by 193. And we take your time to connect them one by one at a time. Escape and continue here. Don't just stretch them one line. That one will be good structurally, because it will be different. It will be a continuous beam, which we don't intend to have any continuous beam. These are one beam at a time on 2 columns. That's for the longitudinal. In the short direction, we said we'll do 200 by 100. which I don't think we have here. So we go to look 200 by 100. We have this one now. So we go to look for again structural framing, steel, and is metric wide flange. Look for 200 by 100. 200 by 100, this one. Okay, and again this will be in the short direction. Escape. Same goes here. Of course, this is typical building. If your building is have different measurement, then you should choose different sizes based on the estimating tables that you have architecturally, maybe Studio Companion or whatever. So we'll see the 3D. So you seem to be fine. I'm back to okay. So now we need to add the concrete slab. We have the columns, beams. Now we need to add the concrete slab, and we do that by going to floor structural, and we'll do a 200. So we'll duplicate this to slab 200 millimeters, and we change the properties, edit the properties. So first we need to change this to concrete and say it is this type of concrete, and of course the thickness is 200. Okay. So now we need to I will use this pick support. These are the beams, so I'll pick this beam and this beam, and then this beam and this beam, and connect them like that, here, and here, and here. Now we need to make sure that this concrete slab is sitting on top of the steel, so I need to offset this by 200, and now accept. So if you go back to any elevation to see it, so we are good here. You see it's sitting on the top of the. So back to level 2. So now we need to add the shaft. On the shaft, so we go to shaft opening. You can choose. I'll just choose this. So and before I go, it is from level 2 and go to level 4. So if I choose just this one and accept, and if I look at 3D, I will stretch this a bit higher. So back to level 2. I will do my shaft. I will remove this part because this is just a symbol for concrete slab. So we'll do the concrete shaft. So we do that by going to wall, structural wall. We'll see 200 generic. That should be fine. Even you can do. Yeah, I think we have 200 millimeters. Okay, 200 millimeters. Okay. So, but we have to make sure you change the properties. I'll call it shaft 200 millimeters. I'll change it to concrete because you could use also block. So we change this to concrete. Concrete 30 is okay. Okay. So now I would like to do the concrete shaft. So we can use pick and decide the exterior, the core face for interior. So when I pick this line and I pick this shaft line and then this shaft line and this shaft line, so I get my. So if I look at the And if I do the shade, I should be able to see it clearly. So I have, this is what I wanted to do. Okay, so fair enough. Okay, so far so good. So now we said we do one thing at a time. So we need to save this as project 2, whatever I want to save it. Now I want to load and do the supports for this project. So go to analyze and do the boundary, and the point is load for fix for this fix. We have done this before. I'm just going to go quick on this because I just want to show you how to duplicate or copy paste the floors, because you need to do that. The only thing you will make changes to is the column sizes, because the beams, main and secondary beams, they are typical if your floors are same. If you have typical floors, then they'll be the same, so you don't need to repeat them all over again, especially if you have a complex project. So just copy. And for the shaft, we'll use line boundary fix again. Now this side and this side, this side and this side. So good with the supports. Now we do the loads. For loads, we have to go first of all to load cases. We don't need these ones. Just keep the dead and live load as we always did. And then for load combination, we do ultimate first. You can call it ultimate one, and the type is ultimate. And add one dead, one live. The dead is multiplied by 1.25 according to Canadian standard, and the live is 1.5. We add another case which is called working, and this serviceability is okay, so we add here. We just change this to live, and we don't need to have any factor, so it'll be 1 1. That's so we go and do load. The area load, the hosted area load will be the one. So for dead load, we'll say it is 4 minus 4 and apply it. And then for live load, we'll have say -3 and apply. So both, this is for the entire area. Now we need to add the wall, exterior wall loads, and that will be again loads, and we have a hosted line load. The hosted line load in the Z direction will be something around 8, say. That is for 200 millimeter or 8-inch wall. We need to do that for this wall, and for this beam, and for this beam, and for this beam. So now we are going to check the first floor for save. Let's send this to Robot and see if this will work. Accept the default and see. Okay, so it seems to be okay. We don't need to see the report. So now let's run the analysis, and hopefully everything is fine. Seems to be. We don't need to see this, so just now if we go to the design to see if, go to seal design and aluminum, and if I do the calculation here, so it seems to be I am fine here. So this is the first part that we did, works. So now the task is that I want to do the other. I'm gonna just close this, go back to my to my project again. So if I go to now, I continue to do the third level and fourth level here. So now first of all we need to go to the third level, and let's see what the columns are here. The column for this level are 310 by 158 or something similar to that one. So if you go to columns and look for 310 by 158, 310. So we need to go to load family and look for structural columns, steel, and metric wide flange. And let's see, 310 by 158. We have it here. Okay. So now we can, and it says the depth we are at the third level. We're going down to level 2. So we'll use at grid and select the entire thing and accept. So we got this part done, and now we need to do the framing. So we don't need to do the entire beams, the long beams and short beams, and so we'll just copy, and the concrete slab will copy the second floor, because it's exactly the same thing, and paste it to the third level. So select everything, we filter, so we don't need the grids to be copied, we don't need the shaft opening to be copied, we don't want the columns because we already have created our own columns, and we don't want the walls because sometimes when you copy the walls we get some problem. So we'll do the walls ourselves. So that way, this is what I wanted to copy. So I'll copy and paste, align to select levels, and I'll do this for level 3. Okay. So it should show this. Of course, this level have been copied with the loads. That's the good thing about it. So now I need to do the walls, like I said. So for the walls, I need to go to walls on structural walls, and the shaft wall is still valid, and I need to go with the pick, and here it says core face interior, so we'll choose the shaft surface lines to create our. Okay, so when I do this, I will do this, I will do this, and do this, and you see the depth is, it goes to the depth of level 2. We're at level, so this should be fine. Now if we go to the 3D, so we have our shaft here. Now I'll do the same thing with level 4. So we need our columns, level 4, 250 by 115. So again, we go to columns, 250. We don't have 250, so we need to go to family and go to structural columns, steel column, and wide flange, and it is 250 by 115. Look, 250 by 115 or something close. 250 by 115, and OK. Same goes here. So depth is to the third level, so we use at grid and select the entire thing and accept. So if we go to 3D, you'll see these are already like that. So back to level 3, we can do the same thing here. We choose copy the entire thing. We filter it to only the floors. We don't need the grids, we don't need the shaft opening, we don't need the columns, and we don't need the walls. Apply, copy. Now we do the copy and paste, aligned, the 4th level. So if you go to the 3D, so I have 3D here. The other thing missing is the shaft. So back, 4th level. Do the same thing, go to wall, structural wall, Same, this is current. We have pick, and it is the interior face. If you pick this, and then pick this, and pick this, and this, and escape. So back to the 3D. I say we are good here. Now if we go to the analytical model, let's see. So good. So now this is ready for export. Now we can export this to Robot. So go to analysis, and then we will export this to so if we go to loads, export to Robot and see it is operational then. It might take some time because it's 4-story building now. Okay, we don't need to see the report. And we need to do the analysis here. So it seems to be fine. We don't need to see these details. Now if you go to the design, steel design, steel aluminum, and run the calculation, so we are good. Of course, the optimization will be in the third video. So that's it for this video.